Boy, we are flying through this module. We're just learning. All right, video 23.1, and believe it or not, that says triangle congruence. Okay, so you want to print out this page right here, 71.1, or again, take a picture if your printer is down. We are just going to prove whether or not a triangle is congruent to another. And in actuality, you would have to measure all three angles, all three sides, match them up, and then if all those parts match up and are congruent, then you have two triangles that are congruent. Well, that's a lot of work, so there's these shortcuts that you can use, and these are the shortcuts. The first 1, 2, 3, 4 are for any two triangles, okay? And then the last one here is specifically only for right triangles. All right, so let's focus on these right here. If you know and you've measured three sides of one triangle and then three of another and they match up and they're congruent, then you are done. Those two triangles are congruent by what they call side, side, side. So basically, you measure the sides, they pair up, they're congruent, and you don't even got to measure the angles. It's guaranteed, okay? Side angle side is two pairs of sides match up, okay? Two pair of sides are congruent. All right, so we've got this side is congruent to this one. Then another pair of sides are congruent, and then the angle has to be the one that is in between or touches those two sides that we're talking about. And that's why they put the A in the middle. It's that specific. So it can't be this angle over here, it can't be this angle over here. It's got to be the one that touches the two sides that we're talking about. Angle, side, angle, similar, except for it's two pairs of angles. So look, this pair of angles are congruent, this pair of angles are congruent, but then it's got to be the side that's in between, okay? Finally, you notice this one doesn't have the S in the middle. If you have one pair of angles and another pair of angles and what they call a non-included side, not touching those two angles, see how it's not touching both of those angles? All right, then that would be what they call angle, angle, side, okay? And then finally, only for right triangles, all you need is a pair of the hypotenuse matching up and one pair of legs matching up, and then by HL, it will be congruent, okay? A lot of people want to guess AAA. Here, I'll slide it over here. AAA, would be like angle, 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 but think about it. You can't control the length of the sides, so AAA does not work. All right, and then the other one that a lot of people like to have fun with, if you read this backwards, okay, so just remember there's no AAA and then there's no profanity, okay, there's no SSA as well. Okay, are you ready to see what fun this is? I picked out a problem just for you, and then we're going to try our first introduction to proofs, and then you're really not, I think it'll be fine, okay? Just don't overthink it. Okay, this works for all kinds of shapes, and but we're just focusing on triangles right now. Okay, so we've got what? Triangle ABC is right here. We got triangle DEC is there. You see the two triangles. Let me make sure y'all can see this. I've got my shortcuts here so that I can make sure I don't screw that up. Okay, well, let's take a look and see what we've got. We've got one hash mark here and one hash mark here, so you have a pair of sides. Okay, so I'm going to put an S. You have two hash marks on segment EC and on AC, so you have another pair of sides. Okay, so if you look at your cheat sheet, your only other option, okay, there's two of them, is you could have a third S, right? We'll put that in the middle, and then you had side, side, side. But look, they didn't tell us anything about side ED, they didn't tell us anything about side AB, so it's not going to be side, side, side. The next one on our list is side angle side, and it has to be the angle that's touching the two sides. So look, this angle right here is touching these two sides in question. Wait, what's that? Aha, very good. From the first couple of weeks, someone mentioned, look, these are vertical angles right here. So these angles are guaranteed to be congruent. This angle is touching the two sides in question, so they're included. So this will be side angle side. Okay? Then you got to do the triangle congruent statement. So I'm going to draw a triangle right here. All right, and I'm going to say ABC. When you start doing your congruent statement, you can pick any order you want, but then when we go to draw the other one, we got to put it in the same order of the other matching parts. All right, so look, ABC comes out here. Look, A to B to C. All right, you're basically taking this triangle and you're flipping it down, right? So if you were to flip it down, A would fall here and B would fall here. So if I go in the same order, it's going to be, look, here's A, here's B, here's C, so it'll be EDC. Do you see if I took this triangle and I folded it at this point right here, or this line, if I fold it over, it would land on top of it, and there's your triangle. If you could see it, there is your triangle congruent statement. All right, I know this is one of those things, you know, you want to definitely keep that cheat sheet out so you can look at it. So now let's do everyone's favorite thing in geometry. Let's finally do a proof, okay? And this is on page 74. And let me make sure I get the diagram and everything in there just for y'all. Sweet. Okay, my sheet of paper to blank all that other stuff. All right, so this is similar to what we did, but it's just in like proof style, that's all. Okay, you're gonna have something called given. Given is like the pieces you're allowed to play this one game. So the only pieces they gave you is AB is congruent to BC. So let's go find that. AB is congruent to BC. And then they say segment BD bisects angle ABC. All right, well, here's segment BD, here's angle ABC. So if it bisects it, this angle is equal to this angle. Okay? Everybody with me so far? So we're going to decide which shortcut it is. Actually, you know what? Why don't we just do that first? Okay, look, I've got a pair of sides, so I'll put an S down. Okay? I've got a pair of sides marked. I got a pair of angles marked. Okay? So looking at your cheat sheet, okay, it could be another pair of angles, but they didn't tell us anything about this angle. They didn't tell us anything about the other angles. Wait, what's that? Oh, wait, look. Those two triangles share this side right here. Okay, so I'm going to put two hash marks on that. Yeah, see how triangle ABD and triangle BCD have that same segment there. And notice the angle is in between the two. So yeah, look, this is going to be side angle side. Okay, so we just did like the previous problem, but now we're going to do it in proof form. Okay, where have you seen segment AB is congruent to BC? Look, it's in the given. I love this one. You just put given. Okay, yeah, when in doubt, put given. BD bisects angle ABC. You're going to put given. Okay, and we marked it on here. All right, how do you know that the angle ABD now is congruent to angle CBD? Oh, how did I mark these angles were congruent? Because you told me this bisects it. So put definition of an angle bisector. So really you're just writing out reasons why. How do you know that BD is congruent to BD? Well, they're the same. I don't know if you remember that one from algebra. It's called reflexive, and I always remember it because I think of like a reflection. BD, segment BD is looking in the mirror and it sees